Hi guys, this is Akash over from BreVITy, and today we'll be looking at a LeetCode based problem. It's called as max consecutive ones 3. So this is a sliding window based problem actually. So if you haven't already watched my friend Vignesh's video about sliding window and this problem in particular, please do go check that video out. The link will be in the description below. Let's look at the problem statement now. So given an array A of zeros and ones, we may change up to k values from 0 to 1. Return the length of the longest contiguous subarray that contains only ones. So what we are given with is an array A that consists only of zeros and ones. So as you can see here, this is an array A and it has only zeros and ones. And what we are also given is an integer value called k, and we are allowed to change k values from 0 to 1 in this array. So we can change at most 2 zeros to 1 in this example over here. So, and what you're supposed to find out is the maximum length of subarray which contains only ones after changing k or without changing k zeros. So if you look at the example over here, we have an array 1 1 1 0 0 0 1 1 1 1 1 0 and k is equal to 2, and the output that they've got is 6. The explanation is they take the last 6 elements of the input array and they get as 6. So how do the last 6 elements become 1? So they change this 0 into 1, and they also change this 0 into 1. So they change 2 zeros which is equal to k, and they made those 2 into 1s, and now they have a maximum contiguous subarray of size 6 which has only ones. So this is what we are supposed to find out. We have an array consisting of only ones and zeros, and we have a number k. We can at most change k values from 0 into 1, and after changing or without changing whatever is the length of the maximum subarray that we have consisting only of ones, we are supposed to return that length. So this is the problem statement now. Let's look at our approach. So the first step in solving a problem is implementation. So we first declare our left and right boundaries. So L is equal to 0 and R is equal to 0. And we also need a variable to store our array size. So n is equal to a dot size. Now we need two temporary variables. One to denote the number of zeros that we have included in a sliding window, and another one which denotes the maximum subarray size that we have found so far. So int z will denote the number of zeros that are included in a sliding window, and it is initialized to 0. And max size is the maximum size of subarray that we have found so far. So even that will be initialized to 0. What we need to do now is run a while loop until our right boundary exceeds our array size. So while r less than n, inside this while loop we'll need to check two things. The first thing is if the element that is pointed to by the right boundary, if it is a 0, that means now we are including a 0 in our sliding window. In that case, we'll have to increment the number of zeros that we have used. So if a of r points to a 0, we increment our z value. So this means that we are now included a 0 in our sliding window. After this, what we need to do is check if the number of zeros included in our sliding window exceeds the value of k. That means we need to check if we have included more zeros than we are allowed to. So in that case, our window would become invalid and we'll need to shrink our window. So while z exceeds k, now we'll need to shrink our window, and to shrink our window, we'll need to move our left boundary towards the right. While moving the left boundary towards the right, if the element pointed to by the left boundary is a 0, that means we are no longer including that element in our sliding window, so we can decrement the number of zeros that we have used. So if a of L points towards a 0, in that case we can decrement our z value and we increment our L pointer towards the next element. Now we move our right boundary towards the next element. At this point, we need to check if our max size has exceeded the max size that we have found so far. So max size is equal to max of max size and r minus l. R minus l is the current valid window length. So at the end of this, we need to return our max size. So this is the code we have so far. Let's look if we have to debug it after running our code. So our code has passed the sample test case. Let's submit the code and see. Our code passes all the test cases, so there's no need to debug as such. The third step in solving a problem is called optimization. So in this code, there is not much optimization that we can do so as it increases, or decreases time complexity, but we can shorten the code. And shorten the code, we'll make use of C++ language concepts such as post increment operators. So what we now have is a separate r++ over here. Instead of that, we can just do an r++ over here. The value of r will only be incremented after it has passed this statement. And similarly, we can do an l++ over here. And since our while loop contains only one statement, we no longer require the curly braces, so we can remove those. So what you now have is a slightly shorter code. Let's see if it still runs. Yep. It still passes all the cases. So that's all for optimization. Now let's look at the time and space complexities of our approach. As for the time complexity, we can see that our right boundary goes from 0 to n at maximum, and our left boundary also goes from 0 to n. In this scenario, each element in our array is visited at most twice. So that would give us a time complexity of O of 2n, but O of 2n is generally regarded as just O of n. So our time complexity would be just O of n. Now, looking at the space complexity, we are not making use of any variable space or a hash map or a vector as such. All we are using is 5 integer variables. So our space complexity here would be constant or a big O of 1. So that's it for time and space complexities. So yeah, that's it for this video. There are a few more interesting sliding window problems coming up this week on our channel. So make sure you subscribe to our channel. So yeah, that's it. See you next time.